David-Enskog was a Swedish mathematical physicist who quietly laid down bridges between kinetic theory, gas behavior, and modern transport phenomena. Born in 1884 in rural Västra Ämtervik, Sweden, he grew up in a large family with limited finances, but unmatched curiosity. He taught himself after school in a chemist's shop, caught up on secondary education while working, and eventually made his way to Uppsala University to study physics. By 1911, Enskog had already published work generalizing Maxwell's and Boltzmann's ideas of gas behavior. He then pursued his doctoral work under Carl Wilhelm Oseen, completing in 1917 with a thesis that tackled how to solve the Boltzmann equation for gases that aren't uniform, an achievement many found difficult to digest at first. Meanwhile, he supported himself by teaching in high schools, writing papers in spare moments, and pushing forward the mathematical understanding of how particles in a gas diffuse, conduct heat, carry momentum, or respond to gradients. One of Enskog's greatest impacts came through what is now known as the Chapman-Enskog method, developed independently by him and Sidney Chapman. This method lets scientists derive transport properties like viscosity, thermal conductivity, and diffusion without relying on overly simplified assumptions. Later, he extended his work to denser gases, accounting for finite molecular size, collision frequency effects, and non-ideal behavior, laying groundwork still used in fluid dynamics and statistical mechanics. Though his academic ascent came late, he was appointed a professor in Stockholm only in 1930. Enskog received recognition. Works dedicated to him, mentions in important reports, including one on atomic weapons research, and election to prestigious Swedish academies just days before his passing in 1947. His legacy is in every equation and model that links microscopic motion of molecules to the world of heat, flow, and diffusion we experience every day. Please feel free to share if you enjoyed this video. Subscribe to the channel Atomic Gear for more scientific content.